Assalamualaikum warahmatullahi wabarakatuh, and good morning to everyone. Okay, so in this video, I'd like to share with all of you, we're now in the new topic of differentiation. So we're in the first part out of five parts of this topic, and here right now we're going to discuss the first part, 9.1 derivative of a function. Okay, so now, please refer to your lecture notes, and we are going to discuss all about this. Okay, differentiation using the first principle. Okay, discuss differentiability of a function at x equal to a. So, derivative of a function y equal to fx with respect to the x can be denoted as the derivative of fx with respect to the x. So, then y prime or dy dx, dfx dx, or y prime or f prime. So, these all are different kind of format of writing the derivative of function of y equal to fx, but they all give the same meaning. Okay, so derivative of function fx using the first principle, as you see here now, and we're going to try to solve or solve all these kind of example here from the beginning question of 1a, fx equal to 3x, fx equal to square of x minus 1, fx equal to x squared, and fx equal to 1 over x plus 1. Okay, class, I do hope that all of you still remember that when we talk about the topic of differentiation, then of course, derivative of the function of, let's say, x to the power of n, differentiate of x to the power of n with respect to the x, equal to, bring out the n here, and then x to the power of n minus 1. Okay, so this is your previous knowledge about this topic from your Form 4 and Form 5 in the topic in the syllabus of Maths. Okay, so might be we call for this question f prime equal to, okay, 3, this is 1 here, so then times 1 to the power of x, 1 minus 1, 1 minus 1 equal to 0, then here, so x to the power of 0 equal to 1. So 3 times 1 equal to 3. Okay, actually that we cannot simply write down or give the answers of f prime x equal to 3, because according to the question here just now, find the derivative of the following function with respect to the x using the first principle, meaning this is only our reference. Okay, this is only our reference. So right now, okay, so let's see it again. F prime x equal to limit of h approaching to 0, fx plus h minus fx divided by h. So f prime x equal to, where the limit h approaching to 0, okay, fx plus h, fx plus h minus fx divided by h. Okay. So then, limit h approaching to 0, fx plus h, this is fx. Okay, this is fx. So then, fx plus h means that substitute x plus h into this x. Okay, 3x plus h. Okay, this is a different part, but just then recall as our previous your previous knowledge in your secondary school. Okay, so 3x plus h. So right now here 3x plus h minus fx, and fx equal to 3x and everything divided by h. Okay, so now limit h approaching to 0, 3 times x equal to 3x plus 3 times h equal to 3h minus 3x divided by h. So 3x minus 3x, then h divided by h. So then limit h approaching to 0. What's left here now? 3. Do you find any h? No. So h approaching to 0, well, there's no h left here, so then it is equal to 3. Is it equal to the final answers that I showed you just now here now? The earliest here, 3? Yes. So this is it. Okay. Then next, fx equal to x squared. So in our mind, the final answer should be, okay then, f prime x equal to 2x. Okay, so no, sorry. Okay, f prime x equal to limit h approaching 0, fx plus h. So substitute x plus h into this x. X plus h squared minus fx, which is x squared, and everything divided by h. Okay, limit h approaching 0. Expand this. Okay, so slowly x plus h in bracket squared. It is an x squared plus 2xh plus h squared minus x squared okay, minus x squared and everything divided by h. X squared minus x squared. Okay, and factorize this, or might be how do I explain this one here? We get h here. Okay, h, one of the h, and also h here. So limit h approaching 0, factorize it, h 2x plus h and divide by h. There you go. So what's left now is only 2x plus h. And when h approaching to 0, and also h here approaching 0, finally it end up with it end up with 2x. Okay, as you see here now. Okay, next, okay, f prime x equal to, okay, for this one here now is also then equal to x minus 1 into the power of half. Okay, so we keep this as a reference for our final answer, which is, okay, f prime x for this one, bring half 1 over 2 x minus 1 to the power of half minus 1 equal to negative 1 over 2, and differentiate x minus 1 equal to 1. Then it is equal to 1 over 2 x minus 1 power of negative half, then come up with square root of x minus 1. Okay, so this is our reference, and we must get these are final answers in our solution. Then f prime x equal to limit h approaching 0, h approaching to 0, fx plus h, square root of x plus h, x substitute with x plus h minus 1, minus square root of fx, which is x minus 1, and everything divided by h. Okay, we cannot simply substitute h equal to 0 here, because if h equal to 0 here and h equal to 0 here, square root of x minus 1 minus square root of x minus 1 equal to 0 and divide by 0. So meaningless here. What we are going to do next is limit of h approaching 0. What I'm going to do here is we are going to, okay, first copy all this again, x plus h minus 1 minus square root of x minus 1, and everything divided by h. We are going to come up with a conjugate. At this time, the conjugate doesn't mean that we to eliminate the square root sign denominator, because right now the square root sign is at the numerator here now, but this is something that we got to do. Okay, so now square root of x plus h minus 1. Okay, the conjugate of this numerator here, please look at this one here now. The middle sign between this and this here is negative, so we come up with positive. Square root of x minus 1 divided by square root of x plus h minus 1 plus square root of x minus 1. There you go. Limit h approaching to 0. Okay, now multiply between these two conjugates, square root of x plus h minus 1 multiplied with square root of x plus h minus 1, then it gives you x plus h minus 1. This multiplied with this positive, and negative square root of x minus 1 multiplied with this side here, and they are cancelling each other actually. And then negative multiplied with negative, negative multiplied with positive, negative, and square root of x minus 1 multiplied with square root of x minus 1, x minus 1, and divide by h, this one here, h, multiplied with all this, square root of x plus h minus 1 plus square root of x minus 1. Okay, so limit h approaching to 0, x plus h minus 1, negative times x, minus x, negative times negative 1, positive 1, divide by h square root of x plus h minus 1 plus square root of x minus 1. There you go. Okay, x minus x, negative 1 plus 1. Okay, so what's left here above on the top here? There's only h. So h divided by h. 1 left here. Okay, so limit of h approaching to 0, 1 divided by square root of x plus h minus 1 plus square root of x minus 1. Okay, so now it's time for us to use this limit when h approaching to 0. So we just assume that h equal to 0. There's only one h left here. Okay, and finally it is equal to 1 divided by square root of x minus 1 plus square root of x minus 1. Same term, right? Square root of x minus 1 and plus square root of x minus 1 equal to 2 square root of x minus 1. There you go. Okay, next question. Solution D. And this also, we may recall, define this as an x plus 1 to the power of negative 1. X plus 1 to the power of negative 1. So then we keep this again as a reference. The final answer, f prime x equal to negative, bring up here become negative, okay, negative 1 multiplied with x plus 1 to the power of negative 1 minus 1, negative 2, okay, negative 2, or we may also write this as a negative 1 divided by x plus 1 squared. Okay, we keep this as a reference. Now, f prime x equal to limit again h approaching 0. Okay, now 1 divided by x plus h plus 1 minus fx, which is 1 divided by x plus 1, and everything divided by h. Okay, so next, when the limit of h approaching 0, okay, so a fraction minus fraction divided by h, which I think that we can simply bring this above here and multiply with 1 divided by h. Sorry. Okay. Now, to simplify between these two, 1 divided by x plus h plus 1 minus 1 divided by x plus 1. So multiplication between these two denominator, so x plus h plus 1 multiplied with x plus 1 is also multiplied, between this one and also with x plus 1. Okay, so 1 over h here. So 1 multiplied with this, we come up with x plus 1 minus 1 multiplied with everything here, x plus h plus 1 and divide by x plus h plus 1 multiplied with x plus 1. There you go. Okay. Limit h approaching 0, 1 divided by h. So x plus 1, negative times x minus h minus 1 divided by x plus h plus 1 and x plus 1. Okay. Now, x minus x, 1 minus 1, and h divided by h divided by h. Okay. Limit h approaching 0, h divided by h. So don't forget that we got negative here. So negative 1 divided by x plus h plus 1 and also x plus 1. So it's time for us now to use the value of h. When h approaching to 0, there's only one h left here. So when h approaching to 0, then this term now become x plus 1. So x plus 1 multiplied with another of x plus 1. The final answer here is negative 1 divided by x plus 1 squared. Okay, so refer to this. We got the final answer here now. Okay, easy, right? Okay. So now differentiability of a function f is differentiable at x equal to a if f prime a equal to limit fx minus fa divided by x minus a. So there's a cases might be one function is separate into two functions. Okay, when x approaching to a from right and limit x approaching to a from left. So meaning that, okay, let's say this is an a. So there is a cases that might be x approaching to a from left and x approaching to a from right with a different function of f1x function, the first function f1 and f2x. Okay, if a function is differentiable at x equal to 0 at x naught, then f is continuous at x naught. Okay, so we'll see what's the meaning of all this here. Okay, now look at this one here. Now look at these two, x less than 0 and x greater than or equal to 0. Okay, x less than 0, and this is the number we call the number line, and the function involved for this one here is 2x. Okay, and x greater than or equal to 0, and this is for x squared. So when x approaching to 0 from left, then we look at the function of 2x, and if limit x approaching to 0 from right, then we refer to this function. So then calculate f naught using fx equal to x squared. Why? Why? Because it's only for x squared that x is equal to 0. You got it? Okay, now, just now, 2x and x squared, 2x, x less than 0. Okay, as our reference here, 2x and x squared. Okay, now limit x approaching to 0 from right. From right is the limit x approaching to 0 from right. The function of fx is from right, which is x squared. X squared minus when x equal to 0, even though, okay, for this x approaching to 0, we just assume that when x equal to 0 here, so 0 square divided by x minus 0. So then limit of x approaching to 0 from right, x minus 0, x square divided by x, so x divided by x, so there's only one x left here. Okay, only one x left. So when x approaching to 0, when x equal to 0, then it is equal to 0. Okay. What about this one here now? Limit x approaching to 0 from left, and approaching to 0 from left, the function involved here is 2x. So 2x minus f0, so 2 times 0 divided by x minus 0. So this is 0. Equal to a limit of x approaching to 0 from left, 2x divided by x. So x divided by x, then limit of x approaching to 0 from left. Do you find any x left here? No. So limit, it doesn't work here. So it lands at x equal to 2. And now, we are going to compare the answers when x approaching to 0 from right, and also x approaching to 0 from left. Are they equal? Are they equal? So we compare this with 2. They are not equal. So, says that limit x approaching to 0 from right and x approaching to 0 from left are not equal. Therefore, f prime 0 does not exist, and f is not differentiable at x equal to 0. That's it. Differentiable, you just recall, spell it. Differentiable, that's it. Sorry. Okay, now a function f is defined as fx equal to x squared minus 1. Okay. Determine the value of k if f is differentiable for all real values. So we are going to find out what is the value of k here, and the key is f is both of this function is differentiable for all real values. Okay, so now the number line where x equal to 1, the first is x less than or equal to 1 is for the function of x squared minus 1, and for x greater than 1 is for function of k times x minus 1. Okay, now so let's substitute with f1 here. f1 equal to, okay, f1 equal to this function, okay, because the sign of equal, okay, referring to this function x squared minus 1. So then it is x squared, which is 1 squared minus 1 equal to 0. Okay, so limit x approaching to 1 from left. So fx minus f1. Fx minus f1, here x minus 1. It is an x squared minus 1 minus f1. X, let's say, substitute x with 1 here. 1 squared minus 1. As you see here is 0. So minus 0 divided by x minus 0. Equal to the limit of x approaching to 1 from right. X approaching to 1 from right here. And just imagine that if I substitute x with 1. 1 minus 1 equal to 0. 0 multiplied with k is still 0. So then, for this one here now, it is k for fx. For fx, we write down all this again. K x minus 1 minus f1. Substitute 1 into this x, so 1 minus 1 equal to 0 times k, everything is 0 here, divide by x minus 1. Oh, sorry, I make a mistake here, sorry. Okay, it's supposed to be 1 there. Okay, now, simplify this. Limit x approaching to 1 from left, it has x squared, okay, x squared minus 1, x squared minus 1, this is a quadratic that can, this is a kind of quadratic that can be factorized. Do you still remember? Okay, let's try. X squared minus 1 equal to x minus 1 and x plus 1. Okay, now simplify this. Okay, x minus 1 and x plus 1 minus 0. Okay, we don't have to write it all again because minus 0 is all gone. Okay, and divide by x minus 1 equal to limit x approaching to 1 from right, okay, then k x minus 1 divided by x minus 1. Okay, now let's see. X minus 1 divided by x minus 1. And also here, x minus 1 divided by x minus 1. Now, let's simplify this again. X approaching to 1 from left, we got x plus 1 equal to limit, okay, limit of x approaching to 1 from right equal to k. So it's time for us now to substitute the value of limit x approaching to 1. Just imagine that x equal to 1 here. Okay, x equal to 1. 1 plus 1 equal to 2. Then nothing x left here except k. So it's meaningless. We don't have to substitute with any x because there's no x left here. So then k equal to 2. So now, the conclusion here, we are at the end of the slide of this part. Okay, so derivative of function f using the first principle and the differentiable of function at x equal to a. That's all for today. I do hope that it helps you to continue your tutorial and your exercise. That's all. Thank you. Assalamualaikum warahmatullahi wabarakatuh and have a nice day.